Hi, my name is Bill Anderson, and I'm going to talk with you today about a little device that's very useful when we're building quadcopters and things of that nature, called the SmokeStopper. I didn't develop it. It was developed by a man in a news group, or a user group that I go to. I'll put the link to the original article in the bottom of this video. I've got one laying here that I built already, and then I'm going to take you through building a new one. And by the way, I'm going to, on the 31st of March, after I post this video, or the 30th of March, I'm going to give away this SmokeStopper to a random user who has, a random viewer who has left a comment in the comments below. So leave me a comment and you may win this SmokeStopper. So let me get to talking a little bit about what it does. Basically, this protects your quad from shorts when you're doing testing. If you short out an ESC, or motor shorts out, or something on the power distribution board gets a bridge across a couple pieces of solder and you've got a short, you won't have to worry about it. This will stop the short dead in its tracks, and let me show you what it does. Instead of shorting out, instead of the magic smoke being released, this light bulb comes on, and I'm going to demonstrate that for you right now. Turn it over here. Okay, I'm plugged into a 3-cell battery right now, and I want to short it out. So I'm going to take this pair of pliers and I'm going to stick it right in this plug, simulating a short, and watch what happens to the light bulb. The light bulb glows. Not only does it glow there, but if I flip the switch, so there's the low end. I had the switch flipped, I'm sorry. That's the low wattage, that's the high wattage. You've probably seen, or you may have seen, other SmokeStoppers demonstrated on YouTube. The big difference between this one and the ones that I've seen, at least, are that they only have the high amperage or high wattage version, and that's really not adequate to protect your quad, because when you're first doing your testing, some of the ESC components and things of that nature are so sensitive to amperage that if you dump the full 2 amperage or 3 or 2.5 amps of wattage, which is what you get with both bulbs on, into it, you can still blow an ESC or something similar that's very delicate and prone to damage to relatively low amperage rates. So let me explain how this works with this picture right here. Okay. The bulb that you want to use, this one is a tail light bulb. It's a 3157 tail light bulb. You can use 3157s, you can use 3057s, you can use an 1157, just about anything that ends in 57. 1157, 4057, 4557, they'll all work. If you want to follow this tutorial, I recommend that you stick with the 3157, because like the 1157, for example, doesn't look like this. It's the bottom end of it is different. It looks like a regular light bulb instead of having instead of looking like this. This is the real bulb right here instead of the drawing. And you can see it doesn't look like a regular light bulb on the bottom. The 1157 does. So if all you can find is an 1157, you'll have to figure out for yourself the right way to wire it up. I'm going to go over the procedure for 3157. And as you can see, you've got 2 elements here. This top one is for the low amperage setting, and it only allows about 500 milliamps to pass through. The bottom one will give you approximately 2 amps. So together you get about 2.5 amps out of this bulb. If you follow the link and read the original article to the developer of this, it goes into a little bit more detail about that into the project. All I really want to do is explain how it works and show you how to put one together. Down here, you can see where the battery comes in, and the power here gets connected to both these filaments on one leg of both filaments. So you're going to one leg of the 2 amp filament into one leg of the 500 milliamp filament. And then another wire is going to come off of the leg of the 500 milliamp filament and go down to the connection that goes to your quadcopter or whatever you're protecting. Then you've got a switch over here that when this shows the switch open, when that switch closes, it closes a loop to the other leg on the 2 amp filament, and then you get both filaments glowing at once, which gives you about 2.5 amps. And I think these numbers are a little conservative. I actually think you get about 2.7 amps, 2.8, pretty close to 3 amps. You can look for the data sheet if you want and see exactly what it is, but that's ballparking it pretty good within a couple of 100 milliamps. So now you've seen one that works, you've seen the picture. Let me go ahead and show you the piece parts that we're going to go put together today. To keep this video relatively brief, I've already made the harness and I've already wired the switch. Because this isn't a soldering video. You don't need to see me soldering up these joints. Just use standard soldering techniques. If you don't know how to solder yet, look for a YouTube video that explains how to solder. You'll be fine. I use TX60s for my connectors. You should use, of course, whatever connector you use when you're building quads or whatever your electronic device that you're trying to protect with this. I've got all my ends already tinned up and we're pretty much ready to go. I'm going to take a moment to talk about the bulb. You want to take the filament, you want to take these little wires, at least one of them, and bust it loose. And this is going to be for the side. Let me show you the picture again. That's going to be for this side here. You can see this line is dotted. That's because that filament is, the connector for that filament is on in the back side of this picture. That's why it's dotted. Where the line is solid, that means that this is it right here. So I'm showing, in this drawing, I'm showing this filament, and I'm showing the one that's a little bit further in by the dotted line. So you want to take this filament, break it loose. I used an X-Acto knife to get underneath this filament, underneath there, and then just break it, just twist it, and it'll break loose like that. And then you just bend it over to the other side. So you've got those two poles really close to each other. Now, let me get rid of this drawing. I'm going to take a little bit of sandpaper and scuff these connections up a little bit. Scuff this one up. It's going to stay right where it's at, although I haven't busted loose. It's not going to move. It's going to stay right there, or so I hope. Now, let me put a little bit of solder on there. That tip is dirty. I thought I was all ready to solder, but I didn't clean my tip. That's better. I'm just looking to bridge these two and leave myself a little clump of solder. I want to make sure it sticks to those wires. Yeah, I need to put a little dot on this one. Come on, tin it. There. And the last one. That's good enough. Now, I'll flip it back over to this side. This is the back side. I want to take the wire that's going to come from the battery, which is going to be, let me double check, the batteries are females, so I'm going to take this, the red wire that comes off this male piece, and I'm just going to hold it down on here. Hold it still till that solder dries all the way. Well, not till it dries, till it cools. Okay, we got one done. Now I want to take the other red wire, that's the one that's going to the quad, and I want to put it on this side here. There we go. Now, this one gets two wires to it. We've got the button here. Now, I recommend you get a button that's marked, or you can mark it yourself. This one says on and off. I mean to have the on side be when it's powering up both elements, and off be when it's only powering up the low amperage element, the 500 milliamp element. So to get that right, I need to solder the red wire again. Turn this sideways a little bit. Right on here with this. That'll do it. And last but not least, I lost a little bit of tinning on the back side of this bulb, but that's alright. The black wire will go to this connector right here. There we go. Now, one of the things that you absolutely have to do with this, because these wires that you soldered all these big connections to, this wire is 14 gauge, by the way. With 14 gauge, and it's got the nice silicone coating, so it's nice and flexible. But those wires you just soldered everything to were very, very delicate. So you have to pop this bulb and these connections in silicone. This one that I'm going to give away to one of the people that leaves a comment already has been potted. It's got silicone in the port in there, and you probably can't see it, but there's also silicone inside of here. So these connectors are very, very solid. They're not going to come undone. They'll last for a very long time. So I still have to pop this before I can actually use it, but we're going to test it to make sure that it works right. There's my battery. I've got the switch off. I'm going to get something to short this out with. There we go. And see if both filaments work. Both filaments work. Ta-da, I'm done, except for potting. So that's basically how you do it. And then when you're finished, when you're working on your quad, you just simply make sure that your switch is in the low wattage position. In this case, I'd want my switch off. I go ahead and plug this end into my quadcopter with this into my battery, and I just check it to make sure that that light bulb doesn't come on. If the light bulb comes on, you've got to short someplace, and you need to take the quad apart and figure out where you left where you bridged something or what you did to cause a short. Then when you want to put this switch on to get both, so that both elements will engage, is if you want to spin your motors up. So because you need more power, obviously, you're not going to be able to spin your motors up on 500 milliamps. You're going to need something closer to 3 amps, which this won't give you quite 3, but you'll get close enough to be able to spin your motors up. And do some testing there, and also if you're attaching it to some ground control software, autopilot, ClearFlight, whatever, you know, you should have this connected to your quad at all times when you're going through those calibration steps that require you to put battery power to your quad, so that you make sure that you're safe. If you have any questions, please leave them down in the comments below. I'll get back to you as quickly as I can. We're going to continue this in a little bit with some potting. I'll show you how to pot these connections. Thank you. Bye. Okay, we're ready to do the second half of this project now and pot these electrical connections, because you don't want to be pulling on these wires over time. You're just going to break the connections and they won't be any good anymore. So we're going to protect our investment and our time by potting these. So I've got some Gorilla Glue 5-minute epoxy. Any kind of 5-minute epoxy will do. There are special epoxies for potting electrical connections. It's relatively expensive compared to regular epoxy, and it's I couldn't find it where you could just buy a little bit. You had to buy like a quart bottle of it. So I just popped mine in 5-minute epoxy. And what I'm going to use is a cofferdam, more or less, if you want to call it that, to keep the shape of the, keep the epoxy from running everywhere, is heat shrink. Now, if you remember from the first half of the video, I had no heat shrink on here. I figured that out right after I got done shooting, and I had to unsolder everything and put heat shrink on it. So, don't mess up, don't miss that step. So, rather than shoot the whole thing over, I'm just going to admit my mistakes, and there we go. So I'm going to go ahead and get ready to do this. I've got my heat shrink on there. And I've got just a little Dixie cup here, got a couple of them, so I don't want it to leak. And I'm going to shoot all this epoxy in here. I probably don't need it all, but I don't want to run short of it. There we go. And we're good. You got to stir this stuff up fairly well. And you don't have much time to work, because it cures in 5 minutes, and it means it. It also gets very hot when it cures. So what's going to happen is it's going to make your heat shrink. So you got to be careful for that. I'm going to shrink this just a little bit around the light bulb. And I'm going to put a rubber band around it. To keep the heat shrink, or keep the epoxy out of the places I don't want it. There we go. And I'm going to pour epoxy in here. Sorry if my hands are in the way of the camera here. There's nothing exciting to see. I'm getting a little sloppy. Some of that epoxy's coming out. Oh, and it's leaking all over the place. I have an epoxy leak. Got it all over the light bulb. That's alright. That's about all we need for that one. There we go. That is full. Pretty much to the max. I'm going to make sure it's settled down in there. I'm going to double this wire over. And I'm going to pour epoxy down this one. Okay. That takes care of both of them. Make sure I got my air bubbles out. And we'll let this set up for 5 minutes. Okay, there you have it. It's all done. The epoxy's cured. You can see that filled it right up. It was only about 3/4 full, and when the epoxy shrunk, of course, not much volume down there, and it pushed the epoxy up, it leveled it right out to the surface. This one overflowed just a little bit, but not bad. It got a little messy on me, but that's not a crime. I'd like to figure out a better way to do the potting than just pour it in shrink wrap, but I can't. Right now I don't have a better method. So if you know of a better method, please leave it in the comments below, and we'll improve the process as we go along. Don't forget to leave a comment, because on the 30th of next month, March 2017, 30 March 2017, I'm going to give this smoke stopper away to a viewer who has left a comment. So please leave a comment, and hopefully you'll win the smoke stopper. Thank you.